This question is always done poorly. And I don't really know why. I'd like to hear some answers for it if anybody bothered to do number 7.
82 inches.
I've got 82. Anybody else? It's kind of an important question because it's something that you guys will screw up as we move into surface area. One piece of wire is 2 feet 3 inches long, which is 27 inches, yeah? Right?
Yeah.
And the other piece of wire is 1 yard, 1 foot, and 8 inches, which is 36 plus 12, which is 48, plus 8, which is 56, yes? Right? So this one's 56. So if you put them right beside each other, it's just 27 plus 56, yeah? But if you overlap them, both of them lose 1 inch. So it's really 26 plus 55, which is 81 inches.
It says the length of the new piece if they overlap by 1 inch. So wouldn't the 1 inch be only lost from one of them because that 1 inch is technically still there in the length overall?
There's my finger.
Okay.
Here's my second finger. 2 fingers, right?
Yeah,
as soon as I move it this way.
But this length is still 1 inch here. 1 inch is lost here, but there's still technically 1 inch.
I'm not losing this inch?
You're losing 1 inch from one of the
Okay.
one underneath, so the one on top still has its inch there.
Okay. Stop and think about this for a moment. Okay? Stand up. Now, if I stand right on top of your head, you're going to add our 2 heights together, right?
Yeah.
But if I drop down 1 inch, then 82.
1 inch is lost from our height.
Okay.
Because you'd be
but
1 inch lower, but I would still be there, so you'd only be 1 inch lower, not 2.
But I'm not starting counting from the end here.
You're starting from
but,
the red end and then down to the
okay.
black end.
Okay. Aiden, if I stand on your head, we add our 2 heights together, right?
Yes.
But if I drop 1 inch down on your height, all right?
Then we
drops
1 inch.
No. Look, where am I starting counting this from? This is 27. Up to there is 26, yes?
Yes.
And then I'm adding 56 inches to there. Right? How long is... No, you're right. How long is the new piece? It's the whole thing. It is 82. 100%. Nope, you're right. Well done, Aiden. Well done. Well done, because I was getting into thinking of... Never mind what I'm thinking about. But no, you're absolutely right.
I was starting to think I was stupid. Like,
no.
I was getting scared.
No, you're absolutely right. Because I'm reading that wrong. I'm saying, yep, nope, you're 100% correct. You lose 1 overlap, not 2, because it's only 1 dimension. Because it's a linear measurement. It's what we were talking about right here. It's a linear measurement. It's not 2 dimensions. Well done. I was thinking about surface area where it's 2 dimensions. I apologize. And class, I apologize to you.
I don't accept it.
That's okay, Max. That's all right. I accept you not doing your homework. So we're even.
Okay.
All right. So the next thing, as we move on, is exactly the same concept, except it's between systems, which means you do the exact same thing. You are still using the conversion method, which is your value times what you want over what you have. So you still need that data booklet sheet, either the one in your book from 2 pages before. Did I give you guys the data booklets?
What data booklet?
I didn't give you guys a separate piece of paper booklet? Okay. take one of these and pass the pile back to Cody, and I'll get through everybody, and there should be some leftovers. That thing that's coming around right now is that one sheet that has all the measurements on it, but it also has every other piece. He doesn't need one. Every other piece of information that you need for Math 10. It's got all the formulas. It's got all the conversions. It's got everything you need for trigonometry. It's even got some graph paper on it if you need it. So you can have that separate so you don't have to keep flipping back and forth in your book. I'll let that get around to everybody for a moment. Now, while that's going around, we can look at this very first one and just show you exactly what I'm talking about. How easy this is. It's the exact same thing. Bowling lane is 19 meters long. What is this measurement to the nearest foot? So I got to convert now from SI to imperial. But it follows the same rule. The value that I want to convert, 19 meters, and I don't need to write the M there. It's not absolutely necessary. Times what I want over what I have. I want feet. I have meters. I get the numbers from the sheet just like I got them from the sheet when I was staying in the same system. So if you look on your sheet there, you guys have the one that says 1 foot equals 0.3048 meters, right? Or do you have the 1 foot equals 30.48 centimeters? I can't remember. 30.48. Okay, so you guys have this one, right? So this is where you have to use your knowledge that you already are bringing to the party, right? You know that 1 meter is 100 centimeters, so you know this decimal's got to move 2 spaces, yes? To get to meters. Which direction is it going to go? The decimal is going to move left because, and this is what happened to Aiden on the very first question, right? You got to think about what you're doing.
You got to remember which way.
You got to remember which way it's going, right? Meters are smaller, are bigger than centimeters. So when I change this number from centimeters to meters, the number has to get smaller. So if I were you guys, I'd write right in here, 1 foot equals 0.3048 meters. Because the decimal just moves 2 places. Everybody good? So we come back to our question that we are working on. This follows the same rule, right? 1 foot is 0.3048 meters. Now, just like yesterday, well, not yesterday, because yesterday was Sunday. Just like Friday, you just do this math. Now, if you've done this a few times, if you've done your practice, it's real easy to remember that wherever the 1 is, you get to ignore it, right? Yeah. So I don't need to do 19 times 1 divided by 0.3048, because I know 19 times 1 is 19. I can forget about it, right? So what I'm going to do on my calculator here, because you really need your calculator when you're going between systems, on your calculator, you're going to do 19 divided by 0.3048.
If you want to be really complicated in this class, you could transfer meters to centimeters first.
Yeah, you could. If I hadn't told you that thing about moving the decimals, then you would have gone feet to centimeters and then moved the decimals 2 places, right?
There does be a unit conversion on page 17 that is exactly what you said, 1 foot equals 0.3048.
So the one in your book has the 0.3048 and the one I handed out to you has the 30.48.
Yeah.
The one I handed out to you came from the very last year they ever did a provincial exam. The one in your book came from the year before the very last year they did the provincial exam. So obviously, the people that make the data booklets were just putting it in basically to mess with you guys. Because they're the exact same thing, right? 30.48 centimeters is 0.3048 of a meter. Just makes you have to do one extra step. So you've got them both. In your book, you got it one way, and in the thing I handed out, you got it the other way. Anyway, when you do that, you're going to get something around 57. There'll be a bunch of decimal places, but it says nearest foot. Is it 57? It's 62?
Yeah.
19 times...
Divided.
Yeah, but when you do it in your head, I can't do 19 divided by that, so I'm flipping it over in my head. So it's 19 times 3, which is 57, and then 19 times... Yeah, you're right. It is more than 57. So what is it? Somebody with a calculator at 62? 62.33, so 62 feet. And other than that, nothing changes. Okay? What do we have to remember when we're dealing with imperial measurements? Do we like decimals? Do we like decimals? No. So this one said the nearest foot, but somebody said, Michael, that it was 62.33. Was it?
Yeah.
Exactly?
It's 62.35.
19 divided by 0.3048. So yeah, 62.335, 62. Now, some of you could argue if you wanted to say, well, Mr. Myers, 0.335 is pretty close to 1/3, right? So you could say that was 62 and 1/3 of a foot, and 1/3 of a foot is 62 feet 4 inches. Everybody understand what I'm saying there? Do I care about this? No, because this is the part I care about. All right, now, if I had said to the nearest inch, then we got to do some different work, right? Everybody understand what I'm saying? If I want the nearest inch, then I got to take that fraction and deal with it. Right? Okay. Read that question and tell me how many conversions you have to do to tell me the answer.
1.
Which one?
Either.
Either one. A bunch of you are going to do this question. You're going to start converting right away. You're going to do them both. And there's no need for that, is there? Okay? Actually, the kids that do both of these conversions here are the kids that show me they don't really know what they're doing. Do you understand what I'm saying? Does everybody understand why that would bother me as a math teacher if you converted both of these?
You could convert the second one to check your work, but...
You could, right? So if you're going to do the mile one, you're going to do 62, and what's your fraction going to be? You're going miles to K. So what do you want? I've already got miles. So I want kilometers, and I'm over miles. So it would be 1.609 over 1, right? What if I'm going the other way? Then I got 98 K, and what do I want? Miles over km, and it would be 1 over 1.609. This way, what am I doing? Multiply or divide? Which one am I doing here? Multiply. What am I doing here? Divide. You're going to do whichever one you want, and then that's going to tell you. I don't have my calculator out because the one on my computer is such a pain in the butt to use. So I do have a calculator right here, though. So what do you guys get?
38.5.
So this one is multiplying. I get 99.76, right? 758.
KM, which you can...
km, which means Hannah drove further, right? Because Farron only drove 98. Now Aiden says, well, why wouldn't you just check? Okay, 98 divided by 1.609
If you're paranoid, then
was 61 miles. So yeah, Hannah drove further. Now, let's say you only do the conversions. You do just this box. Does that answer the question for me?
yeah.
It does the math. Does it answer the question?
No.
I got to see the question answered, don't I?
So someone has to write Hannah.
I got to see Hannah. Or I got to have Hannah circle something to show me that you know what you actually did.
Hey, do we have to show our work, or can we just write down Hannah if we did all the...
No, because that's 50-50. Right? If you just wrote Hannah and didn't write any of this stuff, what does that prove to me? That proves to me you can read her name. Right? I gotta see something. It's a math class. Right? This is a problem that you guys are all going to be facing very soon, but it's not really a problem because the people at the licensing place have a little chart. But people have trouble doing this conversion, right? Why? What makes that distance difficult to convert to metric? Why is 6 foot 2 inches a pain to convert? No, bottle's the wrong answer. Why is that a pain to convert? Don't worry, guys, I got 80 minutes. You got to convert it to centimeters, right? And there's two measurements there, isn't there? So you got to make a choice. Are you going to convert feet to centimeters and then inches to centimeters and then add them? What's your other option? Convert it all to inches and then convert it once, right? So either you do what we did yesterday and then do what we're doing today, or you do what we're doing today twice. Does it matter which one you do? No. But if I were doing this, I would take this to inches right now because I can do that in my head, right? Because I know 6 feet is 6 times 12, which is what? All you people that tell me they know their times tables off by heart. 72 plus 2. How tall is this dude? 74 inches. Now that I only need to convert once. Everybody with me? So what do I want? What goes in the numerator spot? What am I converting to? Centimeters. And what goes in the denominator spot? Inches. And where do I put the numbers? What numbers go where? One in the denominator and 2.54 up top. Since the denominator is 1, am I multiplying or dividing? Multiplying. So it's 74 times 2.54. And what do you get to the nearest centimeter? Should be 148 and then another 37. 175, 177? 187? 188 then. Because we're rounding to the nearest centimeter. Number 4 is a real life problem that is faced constantly in North America. Why? Why is our particular continent really the only place that this problem can exist?
Because we hit bridges.
We drive into bridges all the time, but why do we?
Because they're sometimes measured differently from our cars.
Because if I'm an American guy driving and I see a sign that says 4.4 meters on the Canadian bridge,
That's cool.
it's tough, right? And same with the other way around. So I'll give you an example of this. You know, on the highway just past 232nd Street where that gas station is that has the triple O's?
Yeah.
There's a train overpass there. The next time you drive to Vancouver or home from Vancouver, look at the concrete on that train overpass. And look at how many chunks are missing from it. Because it happens all the time. And when you come home from Vancouver, even more fun, there's a big sign. If this light is flashing, get off the highway. Because there's a laser across the highway. And if a truck goes by that's too tall, it starts flashing and the truck's got to pull over. Except trucks don't always see it and don't always pull over and still crash into the train thing. One time before you guys were born in Vancouver, they were bringing a crane under the Knight Street Bridge, the bridge that goes to IKEA in Richmond. Do you know that bridge at all? They were bringing a crane under that. Somebody measured wrong. The underside of the bridge carried a pipe to bring water from Vancouver to Richmond. They hit the pipe. It was wicked awesome. And the crane fell over halfway. It was so cool. Because I was a kid and I wasn't driving, so the traffic didn't bother me. I was just walking along and I could see it happening. I was like, yeah, those guys are idiots. And then another time in Cleveland, a guy got his truck stuck in a trailer. In a tunnel, because he couldn't measure it right. And the truck was stuck, and they couldn't get the truck out. Everyone's like, oh my God, what are we going to do? Guess what they did? And it was a kid that told them how to save it. It's a true story. Truck was stuck. Into the tunnel. Shrunk. Stuck. Guess what they did?
Hosed it with vegetable oil?
No, they did not hose it with vegetable oil.
I don't know. You said a kid came up with the answer, so I'm just guessing.
Anybody? Kelvin knows. He's heard this story because he was in my grade 10 class. What'd they do, Kelvin? They let the air out of the tires. And they drove it out on its rims. Yes, Wong, go ahead. That's what I just said. Yes, Wong, go ahead. So, again, this question is the same as number 3, right? Do you have to convert both of them?
No.
If I convert meters to feet, am I okay? If I convert feet to meters, am I okay? But I'm going to give you guys a real helpful trick here.
Yeah.
This is 11 feet and 9 inches, correct? 9 inches is 9/12 of a foot, isn't it? 9/12 is 3/4, isn't it? And 3/4 is 0.75, isn't it?
Sure.
Isn't it? 5 3/4. How much money do I have? 75 cents, 0.75, right? So isn't this distance 11.75 feet? Why is that not technically okay? Because we shouldn't be doing decimals, should we? But in Imperial, there's 2 measurements that work out with decimals, isn't there? 3, 6, 9 inches are 0.25, 0.5, and 0.75, right? So I can use it that way. So if I was going to convert that to meters, I can just go ahead and do, when my computer thaws, I can just go ahead and do I want meters. I want meters, and I started with feet. 1 and 0.3048. And I can just do 11.75. If you can do shortcuts like that, it makes your life easier. Because otherwise, you're converting this all to inches, probably, right? So if you go ahead and you do that, what do you get for an answer? What do we get for an answer? 3.58. So the bridge is 3.58 meters. The truck is 3.5. Does the truck fit? Yes or no? Yeah, by 8 centimeters. So you guys take, please thaw, thank you. Do these right now. You can sit with your neighbor if you want, because there's a couple that are a little bit tricky. Number 10's a little tricky, but you can do something with it. And number 11's a little tricky, but you can do something with it. Talk to your neighbor if you want. If you want to move around, I don't care. You got about 2 minutes to get those. 3 minutes.
Sawdust in the box. Am I supposed to take one?
Yeah. You don't have one yet? No. Yep, you can have one too.
Mr. Myers, I wasn't here for like 3 days. Do you have the...
I got the books now. Yeah, they're over there in the box.
Okay.
Hey, man.
Did you just like walking around?
You shouldn't need to for a couple of minutes. You're going to need to, once we go through these, the very next question is that one for how far I drove and how many days, minutes, and hours did it take, and they're not going to be able to do that. But they should be able to put it together, right? Because all conversions are the same, what you want over what you have. And they all know that minutes, hours are 60, 60, 60. We'll see what happens. You shouldn't need to walk around too much now. And then once we do that question, they've got the rest of the period to work. So you may want to just walk around a bit then. Back. On the screen behind me when I push the button is going to show up all of the equations. They aren't going to have the answers. You guys are the ones that are going to provide for me the answers. So that is, I'm going to put them up in a second here. I just forgot to do one. Oh, and I just did that one wrong. All right, now I've got them all, because it doesn't quite fit on one screen. So, now, actually, before I light this screen up, I want to ask you guys a couple of questions. Number 9, number 10, and number 11. There's more than one way to do them. So, because I don't have any of the answers up here yet, if you didn't set it up the way I set it up, are you necessarily going to be wrong? No. So don't jump to a conclusion, okay? Would anybody wish to volunteer their answer to number 5 before I light it up, just to see if we're on the right track? Michael? 80.45? 80.45? Okay. That looks correct to me. Do I have corroboration from anybody? That's how I set it up.
Yeah.
80.45 km. Well done. Would anybody like to do number 6? I have it set up. I haven't done the actual work yet. 16 yards. 16?
164.
It's 164. So, whoever said 16, all you did was you missed a decimal place somewhere with your calculator. You set it up right, but you missed a decimal place somewhere. Number 7. 182.88, absolutely correct. And number 8.
773.8 miles.
773.8. Excellent. Now, you will notice that sometimes people are giving me 2 decimals, sometimes people are giving me 1 decimal. I don't care. But you guys go crazy. So here's what I'm going to say. I want all your answers all the time, unless I specify otherwise, to 2 decimal places. The hundredths. Okay? And, again, remember, if I'm marking it on that 4-point scale and you round it wrong, are you going to get the 3 or the 4? Here is what I mean by that. If your calculator says 73.7725295, what are you going to write down on your piece of paper for an answer for me in my class? 73.77. What if your calculator says 77.7785295? What are you going to write for the right answer? 73.78. Too many of you, when I say 2 decimal places, just look right there and stop. Rounding is a skill you still need. All right? Everybody with me? Will I mark it wrong? Will I give you 0 for a half-page worth of work that you rounded the answer wrong at the end? No. Will I point it out to you? Will I expect better of you? On a multiple choice test, would I be allowed to say, that is A, that is B? Which one would you circle? B, because that rounds to 78. Everybody with me? Rounding is an important skill. You still need to know how to do it.
I'm going to a meeting. If I'm not back by the next class,
I've
written directions.
Okay.
Just tell them to read it and do it.
Yep.
Thank you.
No problem. All right. So, this is what I did for 9. Do you have to follow what I did? No. Can somebody explain what I did there?
You turn yards into feet and then turn the inches into a quarter, like since 3 inches is a quarter
Right.
foot, you did point the decimal form of a quarter.
Does everybody understand what I did there? And Aiden's explanation of it. I took the 8 yards and did 8 times 3 in yards to get to feet. 24. 3 inches is 3/12 of a foot, yes? 3/12 is 1/4, which is 0.25. So I actually had 24.25 feet. And then I took that to meters. Does everybody understand what I did? Is that the only thing I could have done?
You could have turned it straight to inches.
I could have gone straight to inches and converted inches to centimeters, then moved the decimal twice.
Yeah.
I could have done yards to meters, inches to centimeters, and done that. Is there any right way to have done this question?
Unless you're a perfectionist or a huge critic. No.
There's no right way to do it. But is there a right answer?
Yeah.
Yes. And what did you get?
7.39. 7.39 meters.
7.39 is absolutely correct.
Yippee! Hooray!
Now, you will also notice that I am not bothering to write units here. I know that in your previous math classes, you've had teachers say, I'm not going to give you any marks if you forget to put a unit. Please, remember your units. Sometimes it is important.
It just irritates me if I answer a unit.
Will I dock you a whole mark? No.
Got partially.
All right, now, again, I said this is 12 feet and 6/12 of a foot, which is 12 and a half feet, which is 12.5 feet. Does everybody see that? I would never say that I am 5.5 feet tall, would I? I would say I'm 5'6", right? So I would never say the pool is 12.5 feet deep. I'd say the pool is 12 feet 6 inches deep. But when I'm doing a calculation, it's the exact same thing, isn't it? And the decimals make it easy. So who has an answer for me there?
3.81.
3.81.
Every time I answer a question, I take a risk because I'm still stupid enough.
I know you're taking a risk, and I appreciate that you're taking a risk. And believe it or not, even though none of your peers will tell you, they are also thankful that you were the one saying the answers. Because if you were wrong, you're the one that's going to get, no, that's not right. If you're right, and they have the same answer, then they're all going, yeah, risk-free answers. So they're thanking you too, Aiden. Don't worry, even if they're not thanking you out loud.
Thank you, Aiden.
See, Dakota is thanking you out loud. But Dakota's going to give us the next answer, right, Dakota?
No, I don't know math.
Dakota, don't be that way.
Sorry.
15 yards, 2 inches.
I got to check.
Not 2 inches, 2 feet. 15 yards, 2 feet.
So this is a good one. It's 15.61 on your calculator, 6.2 on your calculator, right?
But 0.6.
Now, just stop for a moment. Stop for a moment. Is that right?
Technically.
Is it right? It's 15.62 yards, yeah?
If you're going to decimals, yes.
If you're going to use decimals, it's okay. Technically, what am I going to give you there? 1, 2, 3, 4.
Like a 3 or
That's going to get you a 3. I'm perfectly happy with that. You've done all the math you need to do. You've shown me you know how to make a conversion. How could you get the 4? What part of this is keeping you at a 3?
using decimals instead of turning it to the lower point.
This is the part that's keeping you at a 3, right? How could I make that be a 4? 63.
I think he meant rounding, but
It's 15.616. So it's 15.62. But what could I do to that decimal that would get me to a 4?
since it's 6.6 yards, that means that it's 2 feet. You can convert it to feet because it's the end of yards.
0.62 is almost 2/3 of a yard, isn't it? Right? Because, and this is where this is going to bug Dakota, for example, because she's telling me she's no good at math. You're happy with this, right? You can make your calculator say that. It makes sense. 0.62 is approximately 2/3, correct? Zara. I'm saying that there are some people in the room that might wish to get the best answer they could possibly get. Because that is not the best answer you can get. The best answer you could get would be to convert that 0.62 of a yard into feet and inches, right? So the best way to do it would be to go 0.62 yards times 3 feet. And that would give you your feet. So if you would go 0.62 times 3, that would get you 1.86 feet. So you know you're at 15 yards, 1 foot. And then you've got this 0.86 of a foot. As soon as my screen thaws. That 0.86 of a foot times 12 inches to get 22 inches. And that is the best possible answer you can give me.
0.86 times 12 is 10.32.
Oh, shoot. I did 1.86 times 12. Sorry, 10. 10. Yeah, 0.86 times 12. Yeah.
Scared me there.
Well, it's because I use the answer key. I just push times equals times equals. That's the best answer you could give me. Now, a great many of you are going to want to stop here, and that's okay. But when you ask me on your test, why did the kid beside me who put 15 yards and something get 4, and I put 15 yards and something and got 3? That's going to be the difference. Do you understand? Because it's Imperial.
I was really confused because 162 is okay, but you can't use decimals unless
You're not supposed to, right? Again, it comes down to, what am I trying to do? If I'm just converting and you want to know how far distance is, 15.6, fine, no problem, right? But if you want to show that you're the A+ math student, because we are in school, you can do that.
So
That's what I'm trying to tell you.
a really simple way to put it is that decimals are metric and only
That's the easiest way to do it.
are
Try to avoid decimal points when you're ending up Imperial. Okay? All right, now turn the page over, and this is a true story. 12A will take you about 2 seconds to do. I drove 11,745 miles. My car is a Canadian car, so it measured in kilometers. What was the change on my odometer? So I want km. I started with miles. What numbers go in there?
Oh, 1 mile.
1 mile and 1.609 kilometers. Takes 1 second to do the job. What's my answer?
18,897.
18,897. And is there any decimal points?
Yes.
How many decimal points do I like?
Just 2, so 70.71.
0.71. Took 2 seconds, right? Now, you're going to need to work with your partner to figure this out. If I averaged 85 kilometers an hour, how long did my trip take? But I don't want any decimals in my answer. I want days, hours, minutes. Wait a minute, Mr. Mars, you didn't give us a conversion chart for days, hours, and minutes. Do I need to? How many hours in a day? How many hours in a minute? How many minutes in an hour? How many seconds Oh, I only want you to go to minutes. How many minutes in an hour? 60.
This is further complicated by the fact that we don't know how many hours of each day you actually were driving.
I drove an average of 85 kilometers an hour, and I drove that far. You should be able to figure it out.
Yeah, but you have rest stops and stuff.
Yes, I do. But how long did his trip take? Fine.
If he drove the whole time.
How long did his trip take in driven hours?
There we go.
There, lawyer ball. How's that?
Good enough to be put in court.
Because you're absolutely right. It didn't take me that long. Now, even though you don't have a conversion chart for it, what did I tell you on the very first day we started doing conversions? What always works? Value times want over have. And see if you can figure that out. That's your assignment for the rest of the day. And then you have page 25 and 26
I think I'm doing this right.
for homework. Yeah, you do. You just got to think about it.
Wait, it's Pam. Okay, Pam per hour then. Yeah, just pay attention.
You just got to think about it.
So that's how many hours. Divided by 24 because then there's 20 days. Please be right, because that's honestly the best guess I got. We have to do 25 and 26.
25 and 26 is homework, yep.
I hate all homework. I hate everything.
But most of 25 and 26 is one-step conversion.
It doesn't matter. It's still irritating.